I guess we should start. Yeah. So happy Friday, everyone. My throat is still not normal. It started to get normal on Tuesday and Wednesday morning, and then like Wednesday evening and Thursday it started to get sick again. So I might not project my voice as loudly as usual. I have lots of stuff with me for emergencies, like tea. I have a garlic ginger lemon shot. Anybody ever use that? I highly recommend it. And I have Pro-Drops for emergency. Does anyone have any questions before we start talking about assignment 1? So, assignment 1 is being passed around. There's also a copy on Blackboard. This is a very exciting assignment, by the way. Very, very exciting. It should be called like exciting assignment 1, actually. So it's called Let's Do It Better Than Professor C. So it's worth 15% of the module. We recommend 20 to 25 hours of investment, which is a lot, by the way. A lot. So Professor C was approached by the Public Health Data Administration to help them with a serious challenge. The National Healthcare Service collects a massive amount of healthcare data about national general practice profiles, also known as CCGs or clinical commissioning groups in the UK. The data contains information about each person that has visited an NHS service and the diagnosis that has been given. The data that has been collected for each CCG includes the following. And there are a list of attributes that are collected. Things like the population of each CCG, the age distribution, a summary of the practices, estimated disease prevalence, and then they go into individual health disorders like coronary heart disease, stroke, and so on, heart failure, diabetes, mental health, and so on. So the NHS is collecting lots and lots of data. It's population data, so collective. So you can't identify anybody from this. In addition, each of the above has been collected over a number of years from 2009 to 2014. It's a lot of complex data. In fact, it feels like data chaos. Now, he or she would like to know if visualization can be used to gain insight into his or her data. That's Professor C. So part of the challenge with this assignment is just understanding the data itself. It's not trivial to understand what it is and what it's representing. Right? If you've never seen it before, you get a little shock. Kind of a happy shock. But you will get a little shock first time you see it. As with real-world projects, acronyms and special terminology are abundant. Thus, you may need to conduct some research like Googling NHS terms in order to gain an understanding of the data and its associated terminology. You can watch the following video recording talk to help you get an understanding of the data. So there are talks about this data that you can watch if you want to get a preview and get some understanding, right? They just happen to be on the DataViz YouTube channel. And the first lecture is also on the DataViz YouTube channel. So there's a playlist now called DataViz Lectures 2018 for your convenience. Any Chinese students here? no Chinese students? A few. So I imagine that would be really great. Like you get to hear the language again if you're Chinese, because it's hard to get all the first time. Okay, you can also ask Doris Hain, a fingertips technician specialist for public health data science, Public Health England, any questions. Like if you have very, very tricky questions about the data, there is actually a person responsible for maintaining that data. And there's the URL to download it. Professor C would like to obtain and convey the insight contained in the data visually. The goal is to create visualizations that maximize our understanding of the data, in addition to some obvious factual information such as what's the average size of each CCG, what does the distribution of CCGs look like, which CCGs have the highest incidence of diabetes, and so on. Professor C would like to find out some less obvious things, like are there any interesting patterns and trends, what are the outliers, what insight can we gain, and are there any relationships between the data attributes. Professor C made some attempts to visualize the data using old-fashioned pie charts, bar charts, bubble charts, and line graphs. He was disappointed by the results, which are not very insightful. Can you do better than Professor C? That's the challenge. You are required to select 3 or more appropriate visualization tools for depicting the data set concerned. You are allowed and encouraged to further abstract the data, for example, using aggregation or combinations, adding new data, adding geography, and so on. You could do anything you like to the data. You are expected to make changes. Right? You'll need to make some changes to the data, actually. You won't even have a choice, because it's very complicated. Your task is to produce 5 different visual designs which can convey some meaningful and hopefully interesting insight about the data. You are required to supply 5 unique observations about the data and not just repeat the same observation over and over again. For each design, fill out a description template as below. So there's a description template there that you follow. If anybody's really geeky, that the LaTeX source is on Blackboard. If anybody wants to use it. And you can see an example on page 4. So I've provided you with an example of what a good answer looks like. It's that figure 1. That's an example answer. So your task is to produce 5 plus 2 of these using 3 different tools. So you have the image that you produced, the name of the visual design, the tool that was used to generate the design, the visual mappings. We're going to talk more about those today. A unique observation, and anything you did to the data to get that result. And you have to do better than Professor C. Well, you don't have to, but you're strongly encouraged if you want full points. You want to do better than Professor C, so you have to do something more advanced than pie charts, bar charts, and line charts, and bubble charts. Yeah, that's the idea. And there's a little bit more detail that you can read there. Right, simply creating more standard pie charts, line charts, bar charts is not good enough. Some examples of more advanced visual designs are tree maps, parallel coordinates, matrix charts, scatter plots. There's a lot. There are lots of examples. You'll see many examples in the lectures. If you'd like to get a head start, you can look like at the last year's lectures, for example, the slides on Blackboard. give more examples, or you could just look in the textbook, the recommended textbook, for examples. So the recommended textbook actually has its own website with all the figures. You can actually download all the figures. So part one is to generate five of those figure ones. Then part two is a little bit more like, let's say, creative. You can choose a data set and produce 2 more visual designs using the data set of your choice. However, there are some requirements and caveats there. The data set you choose has to be public, so it has to be available for anyone to download from a public URL. And the data set must contain a minimum of 2,000 rows or in 6 columns if stored in a spreadsheet. So it has to be kind of a certain size. Right? If you just say, oh, I'm gonna take a data set of 10 numbers, it's not very interesting. It just has to be kind of big and challenging. That's the idea there. The data set can't be too simple and offer no challenge. That's the idea. If you're unsure, you can check with me. And you create 2 more visual designs using a template like in figure 1. And some background information about the data. And if you don't want to choose your own data set, I can't believe how nice I am. I've provided a second one that you can use if you think, oh, I just don't feel like choosing a data set. There's a URL to a second data set you may use to do part 2 as well. It's the UK weekly numbers of livestock slaughtered from January 1973 to 2015, available at the website, given the website. Then there's a list of useful tools. I'm sure you're wondering about the tools. There are some examples there of tools that you can use. Times are changing rapidly. When I first started teaching this class, there weren't many options. But these days, there are lots and lots of options. So this is one of the URLs in the assignment for tools. That's a web page with like hundreds of tools on it. That's one of the challenges, is the vast number of tools. So that's a challenge. To help you with that challenge though, I've already created some tutorials on one of the tools. One of the tools is called Tableau. And those are on the Dataviz YouTube channel as well. You can watch those to get an introduction to Tableau. And I make some things like geospatial maps and area charts and stuff like that to give you a little kickstart. Sound like fun? It's a very real-world, applied coursework. It's real, like this is real data. This is actually useful. This is a skill that this is a very transferable skill. Something that is in high demand, this kind of knowledge, and hopefully you can use this when you graduate, like in your next job as well. I just had a meeting with a company called We Predict. When was that? On Tuesday. And there was a student, there are a number of employees at We Predict that graduated from Swansea University, computer science, and a lot of them took the Dataviz module, but one of them was there, and they were studying this exact data, by the way, no joke, because they're interested in healthcare research, and they were using a lot of the concepts from this module to study that data. I was blown away. I was like, this is a great success story. Any questions about that? Sound like fun? Please don't wait until the last minute. Like it takes a long time. This assignment, I would say this assignment's not that difficult, actually, but it's time consuming. It's like everybody can do it. The question is, are you going to allocate enough time? Are you going to give yourself enough time to do it? That's really the question. Okay, another thing is, how many people here are PhD candidates? 2, at least 2. Anybody else? 3? Okay, there are roughly 15 PhD candidates taking this module. Some of them are in Bristol and Cardiff. Some of them are at Swansea. If you are one of those special people, like those 2 over there, you can choose a data set that is relevant to your PhD for this assignment. So instead of using the healthcare, you choose a data set that actually is part of your PhD. So you combine it. I would, though, there is one caveat there. I would like some confirmation from your supervisor that the data set you chose is relevant to your PhD. Just some confirmation. Since you're all physics PhD candidates, it's going to be hard to fool me like some irrelevant data set anyways. Sound exciting? The energy level in the room is just skyrocketed after that. This lecture room is so much nicer than the other one, isn't it? It's like black and white. Carlo?
So you're not interested in the way we produce the design, because Tableau is basically started when we freeze code, so it's not relevant, we can just choose whatever.
Correct.
As long as we achieve the result.
That is correct, yep. Yep. So the range of difficulty level in the tools is big. Some of them are easy to use and some of them are difficult to use. And yeah. Good. If there are no questions, if there are questions, feel free to interrupt anytime. It's fine. Indigo?
Do we just need part 1? Or do we need part 2?
Both part 1 and part 2. Yeah. So 7 of your data set, yeah.
With the data, you said we need to manipulate the spreadsheet, merge and stuff. Do we need to do any cleaning, any normalization and stuff like that, or is not required?
It's up to you. It's up to you. Yep. So, yeah, it's up to you how you want to prepare it. Basically, every tool will have its own requirements, what the data should look like, and every visual design will also have its own requirements. So you'll have to juggle things around. Any other fun, exciting questions? This is a big class, actually. Is anybody feeling photogenic? Carlo, I noticed you put on your makeup today. So. Thank you. Thank you very much.